The shift will be from connecting people and things to connecting intelligence.
Welcome back to our ATxEnterprise series, where we have, interesting interviews with thought leaders in the industry. And with us now, we have Dr. David Soldani. He is the SVP Innovation and Advanced Research at Rakuten. So, hi, David. Great to have you today with us.
Thank you for having me today.
Awesome. Okay, so, we have quite a number of heavy topics that we want to talk about today, but I think, for you, this is your bread and butter, it's your forte, and let's hear it from you. So one of the first things that we want to know is that as telecom networks continue to evolve rapidly, how important is continuous research and innovation in driving all the outcomes, telco outcomes, things like operational efficiency, new revenue opportunities, and long-term growth?
I think this is essential for an organization like thinking of Rakuten Mobile in this case to continue to invest into research and innovation. Research is important, but I think it's even more important innovation. The difference stands on the fact that research typically is more forward-looking, so we think arguments, topics of coming into production maybe into 3 to 5 years from start. Then innovation instead should address more the operator pain points with solutions to be in production in 1 to maximum 3 years since the day we decide to start the project. So it's essential to stay aligned with the technology evolution, and then to leverage technology, new architectures to improve our KPIs. So in terms of cost saving, in terms of risk mitigation, thinking of security, cybersecurity and related things, and the revenue improvements.
So it's essentially the catalyst for organizations to keep moving forward.
Yes.
Okay. So, among the areas that we hear a lot about, in terms of technology frontiers, new technology frontiers, one of them is cloud native, right? Yes. And, cloud native transformation has been at the center of a lot of conversations recently.
Indeed.
And how would you assess the progress that telcos have actually made? And what are some of the challenges that you see in this space?
Yes, I think that the topic has been there for quite some time. If we think the network function virtualization started 10 plus years ago across the ETSI work groups.
Yes.
However, that was not really the solution we need to have in place. So there was more virtualized network functions, and then you have virtual machines. It's still a vertical integrated type of solution which doesn't resolve all the problems we have. So cloud native means now that our workloads, our application, our network functions needs to be designed, developed in a way that they run on clouds.
Yes.
Cloud means Kubernetes, container orchestration platforms, and therefore the network function needs to be simplified so that I have an easy way to deploy them in production as we go, without waiting for any change coming from vendors or other service providers. Where are we today? We have had massive progresses, and then I think Rakuten Mobile is a good example. And I thank you for having us today, having me actually today, because that demonstrates that being cloud native and NI native, perhaps we discussed that too, it is essential for achieving an economy of scale and generate new services at low costs. Right. That's key. And so at Rakuten, for instance, we started the commercial services with 5G about 5 years ago. And now we have an infrastructure end-to-end, completely virtualized. It's all containerized. It's not just about Open RAN.
Yes.
Our architecture is open end-to-end. If you do the core network, and our OSS, BSS is all shaped around the same way. So we have the images, we have our repositories, and then through simple deploy commands, we run them on our Kubernetes platform. So Rakuten Mobile is a demonstration that be cloud native is technically feasible, but also business viable.
Oh, okay.
Where are we with the industry in general? I think massive progresses. If you think of the Linux Foundation, just to mention a few of them, we have now specifications how to comply and have in production function that are truly cloud native. So there is a specification. And then we also have a CNTI project which defines, say, requirements and the specification requirements, so you are compliant with this kind of network functionalities. It's progressing. I think that the next step is to have a massive adoption, not only for the green fields, but also for the other, say, taco operators.
So we are creating a telco.
Brownfields.
Yeah, brownfields, yes. So we are creating a telco that's born in the cloud.
Yes,
yeah,
exactly.
It's born in the cloud. It's not no longer transitioning to the cloud. Systems are built in such a way
in
that
our case,
they are born
it was
in the
born being cloud native. So we decided to have a from day one.
Yes, they are born cloud native.
Hardware and software.
Yes.
And as moving forward, we are now everything goes into containers because that's the most efficiently and effective way of doing it. And we have like Rakuten Cloud now. The Symphony doing very well.
Yes. And I think you have emphasized one of the biggest things that telcos look out there, the viability, business viability.
Yes.
Rather than doing it just for pure technological progress, we now bring it back to business viability. It becomes a critical enabler for long-term growth and profitability. So, because it drives those outcomes. So we're maturing to a stage where we're able to translate this into the business goals, right? So I think that's what telcos are looking out to.
Exactly. So we have not only about the cost savings. So you saw we reported publicly we have around 40% of CapEx, OpEx improvement compared to traditional way of implementing a network. CapEx were also saved because you are not tied to buy that specific box. Right?
Yes.
You can say, okay, look, I want to have this kind of vendors that provides me the compute platform. And then I may think of, find a solution to bring up. But also they generate the new services. Or if you think of automating the DevOps process.
Yes.
And now we think of ML ops. Is extremely simple, simplified. It's all in our control.
Yes.
And that allows us also to launch new services because we have a one unified platform. It doesn't matter if it is a network function. I can have on the same platform network functions as well as AI functions that they communicate, but also other services and application to the OSS, BSS, or IMS, or Link, or whatever other software and services that's consumed by.
Yes, you just plug them in.
Yeah, consumers and enterprises.
Yes. Yeah. I think we talk about cloud native, right?
Yes.
So there's another area. And you've just touched on it, which is AI.
Yeah,
and the term now is AI native. We've gone so fast into AI that we now want to look at how things are AI native, instead of just, again, transitioning, to AI. We want them to be built for AI. So, and I think, because of the importance that we are seeing, I guess, one of the questions is that are telcos ready, to support these AI native architectures and operations?
Yes, we are moving to that direction. Of course, the cloud native. So the ability for the function to be designed to run on cloud is ahead, I think, with respect to ability of the same functions to run on AI platform. And then finally, we want to have our one unified platform where I have ability to run connectivity workloads as well as AI workloads. So we are in that direction. And if you think of Rakuten Mobile, we already have an AI platform in production and it works very well. And we already interfaces our functions with AI. And the first step we have resolved, for instance, and we are also claiming that publicly, was the saving in terms of energy consumption at the edge of the network. So means the radio access, by integrating the AI with our OSS and operations, business processes, we went down 20% of any consumption with respect to we had earlier, achieving the level 4 autonomous, level 4 compliance with the telemanagement forum specifications.
Yes,
So
yes.
yes, we are going to that direction.
Yeah,
I think it's necessary.
Yes, I think, you know, it's sort of has become like an enabler now for telcos to basically accelerate their you know, their move towards really efficient networks, because you want to optimize networks all the time, but if you need humans to get into the loop and start, you know, looking at each decision, each input and all that, but when you give it to AI, you know, AI processes that much information, comes out with decision on itself, orchestrates it, and uses the agentic AI capabilities to make the entire thing like a closed loop automation that's intelligent. You know, it's completely intelligent. And I guess plugging these AI capabilities, like you mentioned, you know, having this as a platform, and you know, all the other systems can tap those AI capabilities.
Absolutely. So the 3 use cases that we have recently shared publicly were on energy saving, which means for us to optimize utilization of cells. So that means that if there's no traffic, we may decide to switch them off, right? Because on the other hand, we may reconfigure antennas. So there are many things we can do to save energy. In addition to this, we have other important use cases, including what we do in my team. I would like to mention the one that also the team published recently at the one conference in Sydney was the way we're using now language models to improve the provisioning of our workloads on cloud, which means typically when you analyze the performance of your applications, and the network function are also applications, you will see that typically vendors, they ask more resources that they want are required for the application to work. So at the end of the day, you have 1,000 clusters, even more nodes that you're not fully utilizing them because they reserve this, but they consume this. So now we are optimizing. So we had a look at the current performance utilization across the logs produced by the container orchestration. And then using the language model, we could reconfigure the network so that now I have, say, a proper utilization of the compute resources as a whole and accommodate more workloads, or may decide to switch off part of the network infrastructure and add more service. And then finally, if I think of my team, we work on cloud computing, ability to program the Linux kernel. So what we do is we use eBPF. eBPF, I explain very easily, stands for Extended Backward Packet Filter. But you may think of a virtual machine of the Linux kernel. So every server, any device, a router, even a smartphone, has a Linux kernel, the operating system. So we have ability to instrument the kernel across all devices, which means by attaching specific programs, we can observe what's happening across the kernel, which is pretty much everything that's happening on the machine. But also we have ability to make measurements as well as security. So that means on that particular server, we can detect if there is an horizontal move or if it is unauthorized access, and we block it. And all of this, return it to AI. What we do is, using our agent, we pass this information to our AI models that they can capture and the different type of outliers or anomaly. And then we report the anomalies. And also we use language model to define the new policies that are then injected back into the repository so that we make our system anti-fragile.
Wow. So it's like using AI to optimize things at all fronts. You talked about how, you know, in terms of sustainability, you know, environment efficiencies, you can optimize the resources. And again, optimize resources for the applications that are running. You know, we don't want redundant space. And then lastly, you know, on the server capacity and capabilities as well, you want to make sure that it's really optimized. So when you
reduce false positive, for example, we reduce of 2 digits false positive, and then make the system beyond resilient.
Yes.
When you
yes.
talk about resilience, it means that you have ability on your network to detect and respond. We go beyond that because we detect, respond, create new policies, so we make the system anti-fragile.
Yes,
Right?
exactly.
When we rebuild the house, we make it stronger.
Yes.
Not just that could be tear down.
These are like
as it was
really
earlier.
super strong use cases for AI.
It
right?
is, yes, and
So-
amazing.
Yes. Okay. So, we've talked about, cloud native and AI native, and, we shouldn't leave Open RAN behind because Open RAN is, I think, Rakuten's baby, and it's Rakuten's clear success area. So we want to see that, since gaining momentum across the industry, we want to know that how the ecosystem for Open RAN is evolving today, and what role does Rakuten see itself playing in this space?
Yeah.
I mean, moving forward.
Sure. So, first of all, I would like to specify that when we think of Rakuten Mobile, Open RAN is not limited to the radio access network. Oran Alliance looks into the radio access network. So that means base stations and then the split.
So does everyone, I think.
Yes, we have applied that concept end to end. So the same thing is applicable to the core network and other part of the network where we host our applications. So openness for us, it's open network, not only radio network. Open network.
I think this is really interesting.
Yes. I wanted to highlight this because everybody thinks about.
Yes, exactly. I mean, if you ask me, a lot of people out there would think Open RAN is like making RAN.
Same. We apply the same principle of openness and the coupling, openness of interfaces and the coupling from the application and the open cloud or the platform across the entire network, including the core network. And by the way, if you look at other operators, they start from core network and then they move to the RAN because it's much more complicated because of the hardware performance overall. The ecosystem is there. It works very well because we have 5+ vendors, if you think of Rakuten Mobile. And then other successful cases, they are also implementing solutions from many other vendors. So the ecosystem is there. The standardization framework has made and keeps making massive progresses. So we do have the Oran Alliance initiative. They do technical specification well integrated with the 3GPP. They work together. And now they are also embracing collaboration with the Linux Foundation. So you may think of Oran Alliance technical specification across the various different interfaces, subsequently adopted by the 3GPP and the standardization body, such as the ETSI, IMDA here in Singapore. And then beyond this, we have the Linux Foundation, a massive amount of projects that look at the compatibility, implementation, and enabling technology so that we don't only have technical specifications, but we also have project and software solution, open source, that you can use it. In addition to specific vendor, extremely high-performing solutions such as the one we have with Rakuten Symphony.
So we are approaching the state of maturity for Open RAN, yeah?
Yes.
Okay. And I guess, talking about all the technologies, these are the main topics that we have. But I'm sure that, being on the research end, there are also other emerging areas that maybe a lot of people don't know yet. Maybe we don't know yet, but maybe you can share some insights as to what are the other exciting things in the pipeline that telcos can look forward to? Maybe 2 years down the road in forums like this, we will hear that in a big way. Do you have any such topics?
Yeah, so I have published 2 days ago an important paper. And
which I'm going to read this weekend.
In this paper, which is 81 pages, I am disclosing, as of today, all the fundamental enabling technologies and architectures that's going to happen in the next few years and maybe 2030 and beyond. Just to summarize where I do see the major changes, improvements, and evolution. So first of all, I have to say that it's going to be an evolution, not a revolution.
Okay.
So if you think of the core network, I think they will evolve.
Yes.
Right? So we have the 5G C core, not yet fully globally deployed. It's going to be there. We will enhance it. we need to improve the way the network functions are designed, but we already are on track according to the CNTI, to the Cloud Native Foundation specifications. Now, what will improve and change, I think, would be the radio interface. The radio interface will evolve because we need to bring AI for the network. So algorithm, the way the communication stack is handled, will shift from the traditional algorithm with shadow packets to machine learning, reinforcement learning type of algorithm. So that will evolve massively. And even more importantly, I think the network will have ability to sense like a radar. That's going to happen in the upper part of the mid band. So think of frequency between 7 to 24 gigahertz. I hope the regulator will find a way to regulate it so that we are having massive use of it. So in this case, the network will have ability to detect objects down to 75 centimeters resolution indoor. Do you know what it means? It can
see through a lot of things.
And then it will have a reliability of more than 95%. So no mistakes in what is, and that will enable massive new use cases. So that's a new technology coming. Then beyond that, I think we will mix AI and communication services. So that means we will have ability to strip the protocols at the edge of the network, which just behind the base stations, where the compute will reside, AI in particular, and exchange services. So I can have intelligent devices in communication with edge devices to realize what I'm saying, the Internet of Intelligence across various type of use cases.
Internet of Intelligence.
It can be I defined the Internet of Intelligence in my paper in 2021. Internet of Intelligence means that you have entities that have ability to acquire knowledge, process knowledge, and make decisions.
Okay.
The one we define as reasoning system or systems. Today we talk about agentic AI workflow.
Exactly.
You have example of Claude Code, right? Or Codex, whatever. So this I am expecting to have a distribution at the edge across the network. And then the Internet of Intelligence will be to provide connectivity among these new entities.
These nodes will actually talk to each other.
Nodes, exactly.
Okay, wow. All the intelligent nodes that are making autonomous decisions using AI capabilities.
Exactly. So the shift will be from, thinking of 6G, the shift will be from connecting people and things to connecting intelligence, the Internet of Intelligence.
an interesting breakthrough idea, and not too far from reality, because the way AI is being adopted, and definitely we see that once you go into agentic AI, the workloads, you see the level of workloads that are put into place to orchestrate a lot of automatic decisions, right? So we expect these nodes to proliferate across so many systems, and like you said, that we are linking all these guys together.
To be distributed, especially at the edge, like where the service is consumed. And you need to meet the latency requirements.
Yes, exactly, because to support this.
Exactly. So if you think of offloading the intelligence of a machine, a robot, on the network edge, you cannot be that far because the decision and control execution needs to stay below 5 milliseconds. And so that means stay below 100 kilometers distance. So you need to be very close.
And those are the kind of use cases that we are projecting in the future, and you need these capabilities.
And you need these capabilities. So you need new technology. We call them deterministic networks. So we need to deliver and have the technology in place where you have ultra reliable, hyper reliable systems, like connecting robots. We cannot lose connectivity with the robots, and then meet the latency. So exactly. This is another area. As it is another area is security. I think security will evolve. Security is very important. So we are talking about post-quantum cryptography. It's not because they are quantum computers. No. The idea is to have the controls on the network that deciphering, so the confidentiality information could be resistant, could resist an attack from a computer with such a capabilities. That's coming.
Yes, exactly.
As well.
Yeah. So we are preparing for this technology that may land in bad actors' hands.
Yes.
So making sure that we can use the same technology to now mitigate those risks from this technology.
Yes.
Well, David, thank you so much,
Thank you for
this brilliant insights. I think, basically you've touched all the main themes that, that we see in this show today. And I guess these are some of the main areas operators are, investing in heavily. And,
Absolutely.
we are all eager to see how the outcomes come to be. And from what you've explained, these are necessary for us to push growth in the telecom sector.
Yes.
And with that, I think, this has been a great session. Thank you so much.
Thank you for having me again.
All right. Excellent.